In this video, we're going to look at the chemical properties of group 7 elements, or what you may call the halogens. So basically, reactions. We shall look at the reactions with hydrogen, we shall look at the reactions with water, reactions with sodium hydroxide or potassium hydroxide, and then the oxidizing agent, the oxidizing action, of these halogens or of these group 7 elements. So basically, chemical properties. Let me bring it in form of question still. Stating the conditions for the reactions describe how group 7 elements react with hydrogen. So there are 4 elements, and they want us to state the conditions and then describe the reaction. So now, with fluorine, if we begin with fluorine, fluorine explodes in hydrogen even in dark. Forming hydrogen fluoride. So the equation would be fluorine plus hydrogen forming hydrogen fluoride. Hydrogen fluoride is a liquid. Then for the case of chlorine, explodes in hydrogen or with hydrogen on heating or it can be in presence of sunlight or one can call it ultraviolet light. Never write UV, write ultraviolet light, form hydrogen chloride gas. So when you're writing this equation, you write chlorine plus hydrogen from true hydrogen chloride gas. Then for the case of bromine, reacts with hydrogen on heating. or this one can take place in presence or in presence. So you pick one to use. Presence of platinum catalyst. Okay. But that platinum catalyst acts at 300 degrees Celsius and you form hydrogen bromide. Okay, so you'll have bromine. Bromine is a liquid. It reacts with hydrogen, which is a gas, to form hydrogen bromide. Finally, iodine. It reacts with hydrogen in presence of platinum catalyst at temperature 400 degrees Celsius to form hydrogen iodide. The question would be iodine. Iodine is a solid. Remember, you need to note the physical states. It reacts with hydrogen, which is a gas. This reaction is reversible to form hydrogen iodide gas. Now you need to be technical with a condition. So even this one, even in dark, it can explode, forming, explodes on heating, or you can use in presence of sunlight, or you can use in presence of ultraviolet light, form hydrogen chloride. This one, bromine, reacts with hydrogen on heating, or you can use in presence of platinum catalyst at 300 to form hydrogen bromide. Iodine reacts with in presence of a catalyst platinum at 400 to form hydrogen iodide gas. So that is it. Then the second reaction we are going to look at, you have to detail this thing as you revise the way I have. The second reaction can be, I can say, describe the reactions of halogens describe the reactions of halogens with water. With water. So we shall begin with fluorine. This reaction with water, very common. So when they say describe, you have to tell us if there is any condition, there's any exemption, everything. So fluorine reacts vigorously with the water to form oxygen or ozone and hydrofluoric acid and hydrofluoric acid. So you'll have fluorine gas plus water liquid, you form oxygen gas and hydrogen fluoride. Aqueous. Alternatively, fluorine plus water we shall form ozone. Ozone is also a gas. And hydrogen fluoride. So you can use any of these. It reacts vigorously to form ozone and hydrofluoric acid, or oxygen and hydrofluoric acid. Pick one and use that. Two, or if you by mistake know both, you can write. But for us, we're interested in Na. For the case of chlorine disproportionates in water to form, we form chloric 1 acid and the hydrochloric acid. Equation. Shall form hypochlorous acid or chloric 1 acid and hydrochloric acid. The same applies to bromine. Bromine disproportionates in water from bromic 1 acid and hydrobromic acid. Hydrobromic acid. Bromic 1 acid, one can call it hypobromous acid. So this is the equation. Bromine is a liquid. It reacts in water to form plus HBr. Then the final note is iodine doesn't react with water. For the case of iodine, you have to show me that iodine does not react with water. So it is by this final note or by this final statement that I'm going to generate another question about iodine specifically, saying, explain why iodine is insoluble in water but soluble in potassium iodide. While iodine is insoluble in water, but soluble in potassium iodide solution. Now, the main thing you should note, first note the difference between iodine and water. Iodine is non-polar. While water is polar. Water is a polar solvent. Now, the intermolecular forces of attraction between the individual molecules of water and individual molecules of iodine are stronger than the forces of attraction between molecules of water. Let me note it for you. Intermolecular forces between individual molecules of water and individual molecules of iodine are averagely stronger than intermolecular forces of attraction between molecules of water and those of iodine. Right, so when the two are combined, the equate forces and repulsion occurs. Repulsion occurs. So it means that reaction is impossible. But for iodine, reacts with the potassium iodide to form a soluble complex of potassium triiodide. It is potassium triiodide. I'm going to explain further. So we have iodine plus potassium iodide. This one forms potassium triiodide complex. Or can have iodine aqueous plus iodide ion. You form triiodide. ion complex. So now that is the logic behind the other one being polar and the other one being non-polar. Repulsion occurs. All right. Yeah, that is the main point. I don't want us to reason it in terms of reduction potentials, but we need to know that its low solubility is because of it being non-polar, right? So that is what we can take. Okay. From here, I want us to go to the reactions of those elements with sodium hydroxide. They can as well say potassium hydroxide, but it doesn't change the chemistry. Now with sodium hydroxide, of course, you have to be very keen and see if the question is specific. Sometimes they say cold sodium hydroxide or hot conc sodium hydroxide. So if they just say sodium hydroxide, just know you will have to talk about both cold and concentrated. So let me begin with cold dilute sodium hydroxide. So it says cold dilute sodium hydroxide. If they say describe, you have to give me statements, products, something like that. So with the cold dilute sodium hydroxide solution, fluorine, let's begin with fluorine, reacts with the cold dilute sodium hydroxide solution to form, we form oxygen difluoride, right? From oxygen difluoride. Sodium, rather we form oxygen difluoride, then fluoride ions. That means that here one will write an ionic equation and water. Or one can say to form oxygen difluoride, sodium fluoride, because the fluoride ions come from sodium fluoride and water. Whereby if you write the ionic equation, this side I prefer ionic because they are easier. So it is fluorine gas plus 2 hydroxide ions from sodium hydroxide. We form oxygen difluoride gas plus fluoride ions from sodium fluoride, and then water. Or one can write fluorine gas plus 2 sodium hydroxide aqueous shall form a difluoride plus sodium fluoride, and then water. Easy as that. Then we go to chlorine. Chlorine disproportionates in cold dilute sodium hydroxide to form chloride ions chlorate one ion and water. So here you can write the equation: chlorine plus sodium hydroxide, which is the hydroxide ions, we form chloride ions plus ClO minus and water, or chlorine gas plus sodium hydroxide forms sodium chloride plus sodium chlorate, and then water. The same applies to bromine. Bromine also disproportionates. In cold dilute sodium hydroxide to form bromide ions bromate 1 ions and water. Where you have bromine liquid plus hydroxide, you will form bromide ions, bromate 1 ion, and water. Apart from fluorine, others have similar reactions, only that the products are different by letters, but they form that similar things almost. So you can form, can write an ionic molecular equation. You form sodium bromide plus NaBrO, then plus water. Iodine does the same. Iodine disproportionates right? Disproportionates in equal dilute sodium hydroxide to form iodide ions iodate 1 ions and then water. In this case, we shall have the equation as iodine is a solid plus hydroxide ions will form iodide ions will form iodate 1 ions and or from iodine, I shall have iodine plus sodium hydroxide 2, then we shall form sodium iodide plus sodium iodate, and then shall have water formed also. So that is the logic. Now, all of them react with the sodium hydroxide in dilute form. Now, the difference is that fluorine forms oxygen difluoride, fluoride ion and water. But these ones, they form, if it is chlorine, to form a chloride ion. Then chlorate 1 ion and water. If it is bromine, to form bromide ion, bromate 1 and water. If it is iodine form, iodide ion, iodate 1 and water. The difference is on fluorine, which forms the oxygen difluoride. Now, I want you to understand that the chlorate 1 formed and the bromate 1 formed, they can undergo further disproportionation apart from the iodine. But the other two, the chlorate ion, the chlorate 1 ion, and the bromate 1 ion, they undergo further disproportionation if you heat. And when you heat them, there you form chlorates. So, or you form the chlorate 5. Now, this is chlorate 1. I call it that chlorate 1. Aqueous, when heated, undergoes further disproportionation to form chlorate 5 ions. So in this case, we shall form ClO3 aqueous plus 2 chloride ions. The same applies to bromate 1. When heated, to undergo further disproportionation to form bromate 5 and bromide ions. Right? Or if you want to compare the molecular ones, I mean that if you have sodium that to undergo further disproportionation to form NaClO3 and the same applies to this. You have that, then it will undergo further disproportionation to form we have that. So that's all about reaction with the cold dilute sodium hydroxide. Okay, so from here, Let's look at the reaction with the hot concentrated sodium hydroxide. Hot concentrated sodium hydroxide. Now, with the hot concentrated sodium hydroxide, fluorine first reacts with the hot conc sodium hydroxide. You have to write all words to form. Now it forms oxygen, fluoride ions, and water. So the equation would be fluorine is a gas, reacts with 4 hydroxide ions from sodium hydroxide to form, so that we form oxygen, and then water. Or you will have fluorine and 4 sodium hydroxide. You form oxygen plus sodium fluoride and water. You have to note how these equations are balanced. That is for fluorine. Then chlorine will disproportionate. Disproportionates in hot conc sodium hydroxide to form chloride ions, chlorate 5 ions, and water. Never generalize this equation. So we shall have chlorine, shall have 3 chlorine molecules plus 6 hydroxide ions. Practice will make perfect to you. In balancing, you form 5 bromide ions. Oh, we are looking at chloride. So you shall form 5 chloride ions plus chlorate 5, and then water. Or can have 3 chlorines plus 6 sodium hydroxide. You form 5 sodium chloride and sodium chlorate, and then water. Yeah, that is it. Then, if it is bromine, to do the same, bromine disproportionates in hot conc sodium hydroxide to form bromide ions. From bromide ions. Bromate 5 ions. Remember, with the coordinate, we are forming bromate 1. So here we form bromate 5 ions and water. So you have 3 bromine plus 6 hydroxide. You form 5 bromide ions plus bromate 5 ions and 3 water molecules. So you can write the molecular by saying 3 bromine molecules plus 6 sodium hydroxide, forming 5 sodium bromide plus sodium bromate plus 3 water. So still you can use you can use molecular equation. Then, and with the iodine, disproportionate in hot conc sodium hydroxide to form iodide ions, iodate 5 ions and water. So we shall have iodine is a solid, 6OH. We shall form 5 iodide plus iodate 5 and water, or have 3 iodine plus 6 sodium hydroxide form 5 sodium iodide plus sodium iodate and water. So those are the reactions of these elements with we looked at with the hydrogen, water, and sodium hydroxide. They can use potassium hydroxide, but the chemistry does not change. Now, in our next video, we're going to look at the oxidizing action of halogens, whereby the reactions which we are going to look at, okay, is where these elements act as oxidizing agents. So let's prepare for that.